Merge divide is a technique that is used all the time in compositing. The technical term is image frequency separation. It enables you to restore fine details or reuse them in other places, whilst keeping the same shading and lighting of a targeted area. There is a node for it in Nuke called Laplacian. It is mostly used when removing elements from a shot and de-aging or aging actors, like removing wrinkles or adding them. It adds another layer of precision when working, but also allows you to work faster. The traditional method would have been to grade a patch to match the lighting and shading to the new area, which is slow and less precise. You can also change lighting without altering details or sharpen out of focus shots. In this basic overview, I'm going to show you how you can use image frequency separation. Here I have an image of a man. He has a lot of fine detail on his face. In this case, we want to remove a mole. Here's an image frequency separation template consisting of a few operations. These operations will allow us to extract the fine details from the image. This is our image and we're feeding it into a blur node, which is going to blur the image and therefore remove all the fine detail. Then we have a merge operation. The operation is set to from in the node properties. The merge is essentially subtracting the blurred image from the original image, leaving us with the details. This enables us to separate the image into two channels. Here we have the low frequency channel, which represents the shading or lighting of the face, and here we have the high frequency channel, where we are extracting the fine details. We can adjust how fine the details are in the blur node by changing the blur size. To understand the math behind this, let's use the slice tool gizmo I downloaded. It is used as a visual aid for demonstration purposes and understanding what is happening to our image. I found this gizmo on Nukepedia. It's a free online library of gizmos and tools that you can use in Nuke. If you view the slice node, you can see I've taken a slice of the image. This is the line it's sampling from. It will display the sampled line in graph form in the RGB values. Our RGB values are represented in curves. Those curves can be seen as frequencies. Our graph is composed of an overall curve, which represents the low frequencies. Next, we have loads of small variations, which are the high frequency details in the curve. We can demonstrate what happens to high frequency curves when I blur the image if we view it. The blur is removing all those fine details. If I deactivate the blur, they reappear. If you take the slice node and connect it to the merge from, where we have a high frequency pass, we can see that all the small variations that were removed from the image have been extracted here. Having separated our image into two channels, we are now able to modify one or both of those channels without affecting the other. Then what we're doing is bringing back the image to its original form by plussing the low frequencies back on top of the high frequencies. If we compare our final result with our original input, we can see there's no change to the image. There is also another way of doing this setup, but with the merge operation set to divide, and we are multiplying the blurred image back on top. This is where the name merge divide comes from. I prefer to use the merge from technique as it's easier to read and explain. You can also extract the high frequency details with Nuke's Laplacian node, which is essentially doing the merge from operation with the blur node. Now I'm going to show you how you can use image frequency separation yourself by creating your own setup. We're going to remove this mole here on his face. To begin with, let's create a merge node by pressing M on your keyboard. We're also going to create a blur node. You can do this by pressing B on the keyboard. Once finished, connect the blur to the source image and the merge as well, but let's use the B pipe. For the A pipe, we're going to connect it to the blur node, as we're going to be using it to take from the image through the merge node. In the merge node, let's change the operation in the node properties to from. You can view a node by selecting it and then pressing any number from 1 to 9 on your keyboard. We're now viewing the merge operation. As you can see, our image is black, and that's because our blur size hasn't been increased. If we look at our blur node, the blur size is 0, which means it isn't doing anything. We're effectively taking our image away from our image, which of course will give us black. If you double click on the blur node and change the node properties in size and start increasing it, you can see that we're extracting all our details. Create another merge by pressing M again on your keyboard and connect the B pipe to the merge from and the A to the blur. Now we can plus our low frequency pass, which is the blurred image, and plus it on top of our high frequencies, which are the fine details. Let's click on merge and change the operation to plus. If you view the merge plus, we're getting back the original image. Let's tidy up our script by creating dots. To do this, press Ctrl on your keyboard and click on the highlighted dots. You can also create one underneath a node by selecting it and pressing full stop on your keyboard. Now let's remove this mole. I'm going to show you the difference between the mole removed with image frequency separation and without. Let's start without. A beginner's natural instinct would be to use a paint node. You can do this by pressing P on your keyboard. We would then use the clone tool in the paint node toolbar menu. If you press Ctrl, you can choose your source. Let's set it something that looks similar to the skin surrounding the mole. Then click and drag while still pressing Ctrl to choose the area you want to clone to. To increase the size of your brush, press Shift and drag. In hardness, we can modify the softness of our brush. I'm decreasing it to 0 to have a nice fall off. The reason why I can't see anything is because I'm not viewing my paint node. Let's view it by pressing any number from 1 to 9. You can see something has gone wrong. That's because this part of the texture has a different lighting and colour to this part. It's not matching the source. The benefit of using image frequency separation is you can keep the lighting and shading of the area you're painting in by only changing the details. In this case, it would be removing the mole without changing the light and shading of the area. I am now going to show you the method with image frequency separation. If we create a new paint node, we can do the same operation over here on the fine details. And if we change the blur size, we can choose how fine the detail is. Let's now use the clone tool again and press Ctrl and drag to set clone source and target, and Shift and drag to increase the brush size. We now need to modify the low frequencies. Let's create another paint node by pressing P and increase the blur size as we're still seeing the mole as it's a bit bigger than a fine detail. We can paint here with the clone tool to get rid of the dark spot. I'm reducing the opacity as my brush is too strong. Let's view our final image. If we compare it to our original image, we can see we remove the mole whilst keeping the same shading of the area and transferring details from another area. If we compare it to our paint node on its own, we're getting a much better result with our image frequency separation setup. I'm adjusting the detail amount with the size slider in the blur node. Let's keep it like that. We have successfully removed the mole. In this example, I'm going to show you how to remove the bigger element from the footage using image frequency separation but for a non-organic element such as the bus stop sign on the road. We would first go about it by moving this area up with a transform node and place it on top. The problem is that it's not matching the lighting and shading of the area. We're getting this horrible dark patch which is going to repeat here. This makes it quite clear where we sampled our patch from, which is an issue. On the left, I've used this exact same method but with the image frequency setup. It's working much better. If we compare to the method on the right, we can see it's transferring all the fine detail of the area sampled without transferring the shading and lighting of the sampled area. Let's create this together. We can start from the beginning by copying our plate over, then create a merge node and a blur node like in the basic setup. Once done, let's connect the merge's B input to the read node and its A input to the blur and the blur to the source. Let's tidy our script. In the merge node properties, we can change the operation to from. Once done, we need to create a merge plus. The merge operation is going to restore our low frequency details with the blurred image by plussing it back on top of the high frequency details. Let's just set our blur size to a value over 0 so that we are extracting some details. If we check between the original image and the output at the end of our setup, we can see there's no difference, which is what we want as we haven't made any modifications yet. If you look at merge from, we can see we have all the details. These are the high frequencies, and on the left we can see we blurred our image. Those are the low frequencies. I'm going to increase the blur size as I want the details extracted to be bigger. Let's start removing the bus stop sign. First of all, we're going to create a roto node. To do this, press O on your keyboard. Now we're going to cut out the area which we want to get rid of. Let's change our clip to no clip to avoid stretching. Now I can create a copy node by pressing K. This will allow us to add the matte or alpha to our image, then attach it to merge from and add a pre-molt, which will cut it out. Now if we view our pre-molt, we can see we successfully cut out the bus stop sign. Let's merge it back on top. If we look at the result, nothing has happened. It looks exactly the same as before. That's because we have just cut out an area and placed it back on top. But now we're going to create a corner pin, which will allow us to position a new area of the image in place of the bus stop sign. Press Tab and type corner pin to create it. I always disable the corner pin at first so I can see what I'm doing. You can do this by pressing D on your keyboard. Let's go into the From tab. This will tell the corner pin where we are translating from. Let's position our points to the area of the image we want to replace the bus stop sign with. I think a good patch to take would be underneath the bus stop, where there's no sign as we have some lovely texture there. Now we're going to reposition this patch on top of the bus sign. To do this, let's go back to our corner pin node properties, set the corner pin 2D tab, which is essentially where we are telling it to transform to. Instead of repositioning the points from scratch, you can click on Copy From to match the point positions to the From tab. Now we can select all our points and move them upwards to our new position. As the perspective has changed, we need to modify the points to match to the new area. If we look at our result, then select the corner pin and press D to re-enable it, we can see that we move the details from here to here. If we click on Merge Plus, we can see what it looks like. We can see that we brought the details back, but we still have one problem. We can still see the blurred bus stop sign. We need to remove this in the blurred output, which is the low frequencies pass. A quick way to get rid of it is to create an InPaint node. InPaint uses surrounding pixels to fill an area marked in the alpha channel or matte input. Let's create a roto for our matte input by pressing O. Let's put the InPaint node and roto before the blur, so if we change our blur settings, we won't have to redo our roto. You can extract selected nodes from the pipe by pressing Ctrl-Shift-X or by shaking your mouse. We can also copy the roto that we did before, so we don't have to redo it from scratch. Copy it with Ctrl-C and Ctrl-V to paste. Then press Ctrl-Shift while hovering over the other roto node to swap them out. You could also just connect the InPaint's matte input to the original roto instead of creating a new one if you don't think you'll need to modify it separately later on. Now if we look at our InPaint node properties, we can change our fill region to matte alpha so that it recognizes an alpha is being fed in. If you want to modify your InPaint nodes, you can change the amount. This sets the amount of stretch applied to the edge pixels. We want it to be nice and smooth, so I'm just going to keep it like this. We can also change the direction. This option sets the direction of stretch. You can use the direction to align linear features. Then we can change the smoothness here. As you can still see the bus sign, we might just have to make the roto bigger. I'm going to copy this roto we've done and paste it here so that they match. Let's view our Merge Plus. You will notice that we have successfully resolved the issue of the yellow bus sign coming through. We're now getting a nice road texture. We still have a problem. The focus of the patch doesn't match as it's not defocused enough. If we switch back to what it was done before, it's quite blurry as it's further away, so we can imitate this by creating a blur node. Let's create a blur node by pressing B and then creating a ramp by typing in tab. Let's then attach a mask to the ramp node. Then we can position these 2 points over here. P1 will be the start of the blur and P0 will be where the blur stops. If we increase the size of the blur, we're now getting a nice blur fall-off effect. The only issue now is we can see the edge of our roto. To fix this, we can put a blur node after the roto to soften the matte. This concludes our bus sign removal. Hopefully this video has shown you how you can be more efficient and precise by using image frequency separation in your work. Check out more tutorials for Nuke on learn.foundry.com/Nuke.